Well, welcome to our session this afternoon at the HxGN Live 2014. I'm very happy to have two guests with me to talk about a topic that is near and dear to my heart, is the simulation and testing of the designs in the early stage of the projects. And the guest I have today is Mr. Dr. Tobias Scheele from Schneider Electric, and Shervin Shokooh, who is the CEO of ETAP out of California. And thanks, gentlemen, for being here. I really appreciate that.
Thank you. It's a pleasure. Thank you.
So the topic of today is we're going to talk a little bit about how analysis, simulation plays a role in the project execution. And I think today, I was engineer myself, and at one point in time when we had a project of $1 billion, we were just celebrating because that was a big thing. But today I see projects coming on of like 18 billion, 20 billion. I mean, they're huge. They're big projects, they're complex projects. How do you see the market before we start talking about analysis software? So how do you see the market of these projects, sizes and the complexity changing compared to like several years ago? Tobias, what do you think about that?
Yeah, thanks for the question, Frank. And going through, we see it in two areas. One is the sheer size of the projects, and as well the complexity, where size and complexity go hand in hand, but we're seeing as well quite complex projects which are smaller, so traditionally greenfield projects. Brownfield, sorry. So the greenfield projects, which are the larger ones, are mainly driven by scale of economy. So it's still the race, as larger your process are, as cheaper you can buy equipment, as more you can have scale effects, and as more you're tapping into resources you have, and therefore naturally the greenfield projects we're seeing in all areas are growing and growing. So when it was common 10 years ago, do certain projects in refining or other areas with a certain tonnage, metric tons per year capacity, that capacity is increasing every year.
Right.
So therefore, they're growing. The projects by itself growing. But at the same time, we are seeing the complexity of brownfield projects growing because in existing environments and existing sites, people want to make expansions, customers want to make expansion, and want to add new capacity. They have to follow new regulation, they have to follow the constraints they have on site. So and therefore the complexity, even of the smaller projects, grows as well significant compared with a couple of years ago.
Right. So Shervin, you see similar things also from the electrical perspective?
Absolutely. I think certainly the scope definition of projects are increasing, and at the design stages, and projects are getting more and more complex because the customers are asking for a one-stop shop with integrated solutions. So part of it, I think, has to do with complexity of project, like you're saying, remote location, a lot of the resources, mines and oil fields, you got to go all the way out to the boondoggles, and there's a lot of that investment, capital investment. Then obviously bringing the technology, the right technology, and then adoption of that technology within your organization to be able to deliver the project adds actually additional capacity, capability, but complexity goes along with it.
Right.
So being able to manage that balance certainly has increased the sort of a transformation on the complexity of the project. We always have complexity in projects. Every decade there's yet a new technology that adds on, but that's certainly part of it.
Yeah. Now the other thing I see, so these projects are getting larger and more complex. I guess we all agreed on that point. But to execute these projects, of course, there is a lot of risk involved. I mean, these big projects are multi-billion-dollar projects. You cannot goof up, and before you know it, you waste millions of dollars. Yeah. So you see also a lot of like joint ventures, and also chopping up the project, like in modular design. I think that is also going to be a challenge for us as solution providers, that these projects are executed a little bit differently, because you cannot do just an 18 or 20 billion project in one office by one company and get it all done. So Tobias, you see also that as a trend, and maybe also as a challenge, this different project execution with the modules?
Yeah, definitely. I mean, as mentioned quite well before, the projects are getting larger and remote. So this is a big challenge for the companies who are executing the project. Right. So when you are building a complete grassroots refinery, close in an area where no industrialization have been before. It's not only a challenge on the project team, it's well a massive challenge later on the owner-operator to operate that. So you need to build the whole infrastructure. And that usually goes into the project as well and makes them much bigger than previously. So, and therefore it's very difficult for one company alone to execute such a project. So therefore, yes, you want to have as limited number of companies or vendors you're dealing with, but the ones you're dealing with, they need to deal with different others to source specific skills they have, and technology we are providing here as well, and you're providing all. Technology needs to adapt to this, so we need to make sure that the collaboration between the different companies and between the different work disciplines is working. In the past, the whole workflow here was very linear, very streamlined. So, and one was finished, giving the work to the next department coming back with results. Right. Now you're coming to the point with these mega projects, that would be a quite limiting factor. So you need to think about, okay, how can you involve several people into it from different companies, making sure they're working on the same standards, and the same tools to bring it together.
That's right, and at the same time, you know, the owner-operator, once the plant has been built, they want a consistent design, even if it's designed by 15 different companies. There cannot be 15 different designs that do not fit together. That would not be good news, right? What do you think, Shervin?
Yeah, and as I said, I think certainly a lot of the companies are understanding, and they actually pay the penalty of rushing into the construction phase of a project without really considering the adequate technology adoption and the handoff, as you mentioned, as well as the entire project life cycle from the inception all the way to the handing it over to the owner-operator. And that has certainly caused extensive costs, delays in schedules, and so it's key to make sure that the adoption of that technology takes place early on, really with the right parties involved, right platforms, and right solution coming together. So it's really the same concept of technology adoption is key right now, and integration of those technology for being able to manage that cost and the schedule and timing.
Now, in the end, of course, the owner is paying the bill. You know, of course, he like the Shell or so, they paying the bill for building a plant. Now, I looked up some studies, and these owners, they say that although we have this wonderful technology today, the technology that we show here in the HxGN, they see that the cost of the projects, the quality of the design, I mean, and the duration of the project execution is not, you know, the cost is not getting lower and the schedules are not getting shorter in their view. It is actually getting longer compared to like 10 years ago. You would think, how is that possible when we have now all these wonderful integrated and smart little tools compared to 10 years ago, and still the cost is going up and the schedule is longer, and there is some concern about even the quality of the design. Tobias, have you heard about that from your owners, or have you seen that trend or that concern? And if so, what do you think that's the reason there?
That's actually a good question, but needs as well a little bit subjective. So to say, what does it mean projects have become significantly more expensive? You need to find the right baseline, so to say. So, and yes, the tools we're having, increasing the efficiency, so increasing the engineering efficiency, allowing the collaboration, but as well on the other hand, adding complexity, but the complexity doesn't add to the cost. So what we are seeing as cost-adding items is, for example, remote locations. So, and as well, when you're looking on some of the projects, in the past, they were done in an environment which had already a well-developed environment, like utility system was there, supply was clear, demand was clear, and some of these new mega projects got built in an area where this all is not there. So the infrastructure needs to be built as part of the project, and that infrastructure adds a huge cost factor here. At the same time, the regulations are getting from year to year significant higher than previously. So therefore, not only about safety, but as well energy consumption, reduction of emissions. I mean, all these items play into account in making, of course, things more expensive. And new technologies is required to fulfill these regulations, and they need to be invented. So, and some of them are still not there. There come regulation down where the end user currently has no idea how to do it. So it needs to be developed. So therefore, the general statement to say projects getting more expensive, I would be careful with that one. So
no, but I was driving exactly to the conclusion you put at last. These regulations, the remote locations, new technology and more expensive technology often has to be applied in order to fulfill those new regulations and requirements that the owners have to do, you know, and safety, like you said, very important.
I would add also the human resource skill set needed to run these technologies and be able to do these types of analysis
good point too.
and so forth. And finding the right skill sets, having the strategy to be able to position yourself, to bring the right disciplines, right people, right. Companies together, and that also adds to the cost.
Yeah, no, that's right, that's a good point. Now, both of you, you're in the process simulation, and you do electrical analysis, and I know your products can run, you know, on their own, stand on themselves and do the job. But what value and what's your view on marrying those tools that you have with the Smart Plant suite, the design part of the equation? What benefits, what do you think that we can bring to the industry, to the owners, to the EPCs with a combined solution?
Yeah, so I mean, that's a very good question, and it's clear to the heart of what we are looking from our side strategic perspective. So what we are all doing is supporting the plant life cycle. So when we are talking about a plant, for us it's a physical asset in the process industry. It's huge, it's expensive to build, it has several steps, several departments who need to work together. It all starts with the process engineering, goes over basic detail engineering, construction procurement, and then operations. So it's a whole life cycle here. So in each element of that life cycle has different tools and different people and different departments, different companies who need to work together.
Yes.
So, and at the moment, there is, I mean, for each of these areas, the best-in-class tools, we are providing a couple of them, but we are seeing a big advantage of integrating them further because it allows, on the customer side, to really integrate their workflow. So, or to requesting an integrated workflow, which takes risk out of the schedule.
Okay.
So, which is, on one hand, is able to reduce the schedule to a certain time, but even more important is to allow parallel execution of certain tasks. When you have a well-synchronized information flow between the different tools used by the different departments and have the right rules in place and the right mechanics in place, you can start certain tasks which in the past have been completely sequentially and parallel, and that takes an enormous time out of the project schedule. Right. Therefore we see a need, we see a demand on the industry, and we see a need of integrating these tools further, not only ours on our side what we are doing, but as well with third parties like you or you as well.
Yeah. So Shervin, what do you think?
Yeah, so I'm sure you and I talked about in the past, you heard me say the value of a power ecosystem.
Yes.
And in the electrical world, I kind of coined the phrase power ecosystem. Yeah. And that's where you have the integrated approach between best-in-class solutions, such as ETAP and Smart Plant. And when you bring these solutions together, it adds value to the end user, obviously. Why? Is because interoperability, data exchange between these platforms in this power ecosystem, it starts from the design stage. It's the perfect system, I say, starts from the design phase. Yeah. And bringing those at the get-go, it increase the quality of the design. It adds value to that, reduces the risks, improves the analysis and more accurate analysis, but ultimately what it gives you is to the end user, gives them a decision-making tool, informative decision tool that they can rely upon, because these solutions coming together, offering the entire life cycle, like you're saying, from the inception, from the feed stages, all the way to the operation and planning. And again, circling back to the whole life cycle. So that's where the value comes in.
Yeah, right, yeah. I agree, and that is, I've been talking, for the last couple of years also on making the right decision early on, because coming from the engineering world myself, I know that you have to make assumptions in the beginning sometimes, because you don't know exactly what vendor you go with for instrumentation or electrical equipment, so you have to make some assumptions, which is okay, but if you make too many assumptions and errors and you have to correct that, you get this whole iterative, you have to change it and change it and change it. Do you think that the solutions that you are both are offering will enable that? You already alluded a little bit to that just a minute ago, reducing the risk and giving you the information or the tools to make this right decision earlier, earlier on in this whole work process. What's your view of that?
This is one key heart of what we are doing and the whole purpose of the simulation we're looking. So what we are looking for is that we're having a model-driven engineering. So, and here what we mean as well is that your information, model is storing information of your process, and it's getting richer as you're going down the engineering lifecycle. But what it means as well, as it gets richer, you need to correct assumptions. And when you are correcting assumptions later in the lifecycle, I mean, in a traditional sequential process, it can have significant impact if down the road you're realizing my assumptions on feedstock are wrong. My assumptions on location of utilities are wrong. It can be huge expensive if you need to go a complete iteration back. So the question is, you need to make sure that the information flow as seamless as possible. It can be notification, it can be saying, okay, what are really the changes needs to be done? You're having a recheck to see, does this have an impact on the design, or can I live with the design? Is the design envelope large enough? So this is all what we are looking onto, the technology has to provide. So that's what we are looking on, our technology does at the moment. So but this requires as well diligence from the customer to spend the time at the beginning to do a proper design and to set the system properly up. Even under the knowledge, I don't know everything, but what I don't know, here's the flag. So as soon as the flag got filled, what is the impact? What is the impact? So there will be iterations for sure, but they need to be highly automated, they need to be highly guided, guarded, and driven by milestones. So say, okay, now I'm at the decision gate, what am I doing now? Do I need to go back? Do I have a massive design impact, or good, go ahead?
Right, yeah, and I agree with you. We have this famous chart that's, I don't know, maybe 20 years old, where you see this curve that in the first 2% of the life cycle, you make basically all the basic decisions. So spending a little bit more in that little piece on the beginning has a huge impact downstream. So I agree with that. So you really think, I mean,
it goes back to making a right decision early. It's a strategic decision and has long-term benefits. And I think to your point is, we call it the active blueprint of the system, is having this model-based system that if you put it as part of your management of change early on in the design, and know that once this is passed over to the end user, to the operator system, this active blueprint could actually save you time and money down the road, from optimization to simulation. This is the whole cycle again. And that is something that maybe a few years ago wasn't understood or appreciated by a lot of the owner-operators, but now with the technology, it's becoming essential. It's actually become demanding, and it's part of the specification. I'm sure you see it in your industry. It's becoming part of the specification, and thou shall have a design tool that goes on to become part of the life cycle of the plant.
Now the other thing is that, I don't know about you, but I get a lot of requests, especially lately, from customers that says, well, I need to reuse the design, or I need to have an existing design that I keep on improving. Like you said, maybe you do a process design, or you do an electrical system, you have implemented that, but then maybe you get feedback from the field, or you need to improve it. So, sometimes you have a template design, but you want to use it again, but then add to it or improve it. What's your view on that, on reusing design and making it a little bit better based on some feedback from maybe operations or something?
Yeah, so this is really then in the hand of the owner-operators and of the process licensors. So we're getting the demand from these areas. Process licensors specifically, that's what they're doing day in, day out. So if they are licensing a specific process, they are much interested to automate as much as possible. So of course they need to take into account different feedstocks, locations, demand, quality grades, but at the end of the day, they try to stay as much standardized as possible to again take out the risk and take out the cost. For the owner-operators, it gets to the point, after day one usually, there are some changes required. So and how do you make sure that your information stays current? So that when you're going in, as I've described, the life cycle of a plant, so when you're going into a revamp situation, which is happening these days earlier than in the past, that you have all data on hand. But this requires as well from a customer side a certain amount of diligence, so to update the information, to keep it current. We as a technology provider can help here a lot. But ultimately, this is something where the customer has to put this as well on his dashboard. So to say, I would like to have this because I want to reuse the data later on. Technically, feasible.
You see that, Shervin, that they want to just reuse template design and improve, or?
Absolutely, it's really, again, it goes back to the life cycle. What you do as part of the operations, and knowing what the expectations are, you plan that early on in the stage, even the integration, commissioning, and then planning stage. But to your point, I mentioned on management of change and having that built in, it's really a handoff between the EPC and the owner-operator. That has to be understood. With these types of solutions, when you're talking about design and simulation offline and design and simulation online, or the predictive analysis type of optimization, these really have to be built in and burnt into the DNA of the owner-operator system, because without it, the system could get out of spec, or it's not going to meet the requirements of the system as the system expands. Especially we see that in oil and gas distribution fields when they're adding more wells and more reservoirs. It's always a constant challenge of maintaining the electrical system and keeping the, feeding the next well. So it has to become part of the process that they manage this growth and becomes essentially a template for better design in the future and the expansion, so it improves the system reliability. Because tomorrow you're adding yet another system or modernizing another portion of the plant. So absolutely.
Yeah, that's very. And then follow up with the question for you, Shervin. I mean, obviously, we have been talking about designing plants and always, at least in my mind, you get this brand new plant. That's always cool, greenfield. You start from the front. You can do everything you want. But the majority is either brownfield or what about the operational phase? When you have designed your electrical system. The thing is installed, and now the thing is running. What can we do with our technology and tools that we have today to help the owner to run as efficiently as possible and avoid critical machine stopping, and that type of thing, just managing your power system.
Yeah, great question, and this is really what we have done really well in the past 15, 16 years is when we started introducing our power management system. It was what we coined the phrase model-based power management system.
Okay.
So it starts from a model, active DNA, active blueprint of the system, which brings the electrical information from Smart Plant Electric, for example, and model of the system, engineering parameters, then time synchronized with the operation data. So for example, an operator in an oil refinery, an offshore oil refinery, wants to start a 10,000 horsepower compressor, he can simulate the start of that machine using the current generation active loading of the system, status of switches and breakers in the system, and see what will happen. Does that 10,000 horsepower machine is going to sag the voltages? Is it going to impact, shut systems down before he actually takes that action online? So it reduces the human error, it reduces the impact to the operation, minimize that greatly. And we've seen that over and over in the industry, especially in the process industry, that these tools are becoming a must-have, almost borderline of safety systems, that you have to have this operate assist and assimilation. So the need for having this active blueprint or model-based power management system, what we call it, is used to be something that was a futuristic concept for a lot of these folks in the industry, but it's becoming a very easy thing to implement because the technologies are there.
Yeah, okay, that's great, yeah. So obviously you are also playing a big role in the owner-operator phase with your tools when you want to tweak the process, I guess.
Yeah, I mean, this is actually two elements, or we have two elements of our key business are playing here. One is the simulation and training, and the other one, the online optimization application. So design was what we talked at the beginning, so that's when you're designing your plant, but the majority, a big chunk is coming when you're operating them and starting them up. So we have leading technologies for training operators, like you're training pilots in a flight simulator. We have the capabilities to mimic a complete process plant. So behind is a process model. So then we are simulating the control system, the safety system, any other third-party system you have, and the HMI. So the control room, instead of having the control room operator operating on the real plant, you're sitting in a mock-up of the control room and he is training. It behaves exactly like his plant, and you can have him trained in all the scenarios. You don't want to have him ever happening in his life, but you want to have him reflexes on that, so that he knows exactly when something goes wrong, what to do. So, and this is a key element of our business and one of our fastest growing businesses, because not only for greenfield, but massively for brownfield as well, specifically to the aging workforce issues, the lack of skilled labor, so people need to be trained in operating, and not only safety, but as well economically most efficient. So you want to have them immediately reacting. What does a great change mean? What does it mean if in the middle of the night something happening, it's a failure measure, what am I doing? So but the third part is all about online optimization. So we have as well a big part which is advanced process control. So the normal control system, what it does is operates your plant in a safe and reliable operating envelope. It doesn't push in any direction here. So an APC can push in a profitable direction, but as well in a certain envelope. So what an online optimizer does, that's the other element we have here as well, is that it takes into account the thousands of variables you can get out of a process plant, and the hundreds and hundreds of objective functions, and whatever you want and variables to manipulate and find the one optimum. It can be an optimum in terms of quality, in terms of cost, in terms of quality and cost, and then pushes back what are the set points into the system. So that's really like the top end of what you can do to squeeze out capacity in existing plants, and we're seeing this as well. It's quite decent growing market.
Right. So I think both your solutions together with the smart plant, you feel that we can impact CapEx as well as OpEx.
Yeah, both. Absolutely.
I think so. Right. I think that's good.
Has to. It has to. That's right.
Yeah, that's right. That's our goal as well. So. Okay, cool. Well, you know, before we close, I want to give both of you an opportunity to add anything that you want to add to the discussion. If you feel we left anything out, or if you want to bring anything up, then please feel free. And
yeah, maybe one item, and we've discussed since a while about it as well in some other sessions today, so that we are looking forward to the really model-driven engineering. That we are saying, look, I mean, we would like to have really a model following the whole process engineering lifecycle up to the plant lifecycle. Don't stop there. So and then the key thing here is really how does the information flow between the different departments, between the different tools? How do we make sure that the information flow is given, and how do we make sure that we as vendors addressing rightly what the customer's expecting from us here? So and we're seeing the future in a model-driven engineering. So that means as well integrating the different applications and tools from third-party web, taking into account how can we reduce the CapEx and OpEx of the customer side, and how can we start really certain elements of the engineering flow in parallel, so that we see the long promised, not happened yet, reduction in the engineering time. So not of the man hours per se, but from time of inception, as you have mentioned, to the point, hey, I pressed the button, the asset is running, it's still a long time, and we haven't made a lot of. I would like to see how can we significantly reduce that.
Right, and the other aspect is that I'm also keen on, that we address with our solution, is that we are providing a solution that enables the owner also to be more competitive with his solution and more cost effective, like for instance use of energy in the plant. So Shervin, anything that you would like to conclude with and add?
I would say to your point about really what is needed right now in the market and what is the market expecting and will be expecting is really needs to be addressed by the likes of our solutions. And we're already addressing it, so such as, for example, cloud connectivity. And being able to do these types of simulation, engineering design on the cloud, accessible on mobility basis, on the web-based solutions. I remember almost 12 years ago or so, I would go out to the customers when I used to be more on the business development side of the work, and would say the next generation of power system analysis is using online data. And that concept is really today, I would say it's yesterday, because it's already been spec'd in. Today is all about connectivity, integration, and that's expected. What I also see as today, and one of the things I take pride in our company, is we really look 5, 10 years plus and really look at the technology. Today is the Google age, right? So you go in Google, you type a couple of words and you get 20 different results, and it already is thinking for you. It's anticipating what you're going to do. And this is what has to be brought into the technologies that we offer. We really are striving to do that in ETAP, and we anticipate and predict the knowledge. So today's generation may not expect it as much, but the next generation of engineers, this is becoming a requirement that you should think for me to some extent, that anticipate what the results are going to be. And I think that's really what we all have to strive towards as companies.
Great. Well, gentlemen, Tobias, Shervin, I really appreciate you being here this afternoon. I thought it was a very good discussion, very interesting discussion, and I would like to thank everybody, and I hope you enjoyed the session. Thanks.
Thank you.
Thank you. Thank you.